All right, welcome to the module about neoplasms and cancer. The study of neoplasms and cancer is an excellent example of altered cell function due to genetic and or environmental causes, and to apply many of the basic concepts related to genetics and altered cell tissue biology that we did earlier in the course. As I'm sure you know, cancer is one of the leading diseases in the Western world. Question is cancer increasing in the U.S.? Well, we can talk about that a little bit, but what I like to do is refer people to the SEER data, S-E-E-R data from the National Cancer Institute. You can go ahead and Google that, the SEER data from the National Cancer Institute, and what you can do is look on there, and it actually gives the actual statistics of cancer for pretty much as long as they've been tracking it for many, many years. And what you'll see is if you start looking through all the various cancers, you know, the breast cancer and prostate and lung cancer and colorectal cancer and any kind of cancer you could possibly think of, if you start looking through there, what you'll see is you will see trends. And that's what you should look for. But you'll also see that they vary quite a bit. They go up for a year, they go down for a year, they go up and down, and they're all over the place, and you can look at any particular time frame, and whatever happens to be your point, you can go ahead and prove it with this SEER data about cancer. So what happens is that if you look on the internet and you look up any particular cancer, what you'll find is that it's going up. And what you'll find on another website is that it's going down. And what you'll find on another website is because of one thing, or another website because of another thing. And that's kind of the problem when people ask, you know, are we seeing more cases of cancer? Well, it really depends. There are many different kinds of cancer out there. And it certainly depends on the age of the person, the sex, the ethnicity, the geographic location, the type of cancer, of course. To answer that question is nearly impossible because there's just so many different factors that go into it. And quite frankly, with the statistics, you can make your case no matter what your opinion is, and that's kind of what people do, is whatever their agenda is what they're making their case for, and you can use those statistics to actually prove your case. So, you know, one thing we do know is that, you know, people are living longer, and we are seeing more cancer because of that reason. But we also know that we are curing more cancers too. So the rest of it, you know, is really definitely up for debate, no matter what the claim is. Anyway, it's obviously for reasons like that, it's imperative that all healthcare providers have a strong understanding of cancer and its characteristics and causes. You have to be able to understand the progression of cancer, the consequences, the treatments associated with neoplasms and cancer. You got to be well versed on the different invasive mechanisms and manifestations and treatment options, including side effects. So we're going to go ahead and talk about neoplasms and cancer in this little thing here. So let's start out with talking about tumors. Okay, the term tumor is used to refer to any swelling historically. Now it's more commonly considered synonymous with the term neoplasm, and it really what it refers to is a new growth resulting from abnormal proliferation of a given cell type. So it's a new growth. Okay, that's what a tumor is. A benign tumor is one that's usually encapsulated. Okay, that means that it's made up of what we call differentiated cells that are similar to the cells from where they arose from, and it has a capsule around it. So what makes it benign is it has that capsule and it can't really go anywhere. Okay. They don't invade other tissues, they don't spread to distant sites when you're talking about a benign tumor. They can, however, be life-threatening if they grow in critical areas and crowd out other tissues. Think about maybe a pituitary adenoma that just gets really big right inside that cella turcica in the brain, and grows, really, really big, crowds things out. Meningiomas are pretty good for that. They simply just crowd out other things, cut off blood circulation, squeeze nerves, whatever, and they can obviously be, deadly from that reason. Benign tumors, again, they're usually named from or according to the tissue from which they arose, and they have these suffixes, oma, O-M-A, on the end of it. Okay, so what you'll see like an adenoma, like if it came from like a glandular epithelium, or neurofibromas, maybe an osteoma, so from the nerves or from the bone. So you'll see lots of things like that. On the other hand, cancer refers to encapsulated. Cancer refers to a malignant type of tumor, and they grow rapidly or fast, and they're not encapsulated. They commonly invade neighboring tissues, or they metastasize, meaning spread to distant sites. Characteristics of cancer are usually the result of an accumulation of separate genetic mutations that lead to an autonomy from normal cellular controls, or stated simply, you have to have usually at least 3 different genetic mutations that cause these cells to basically run themselves. They break out of the system, if you will. Okay. If the cancer is found in the tissue it originated from, we call it primary. Okay. So, wherever that cancer happened to be, whether it's testicular or colon or lung or brain or whatever, if it's still there, we call it primary. Okay. Once it spreads to another organ, that new location is called the secondary site. So that's what we're talking about right there. All right. A low-grade tumor, that's what we say is well-differentiated. So that's another word for it. A low-grade, well-differentiated, probably not. It's similar to the kinds of cells it started with. Okay. On the other hand, if you're talking about anaplastic or anaplasia, that's the loss of cellular differentiation, and that's characteristic of cancer. You also lose the cellular adhesive properties and an increased motility of those kind of cells too when you're talking about cancer. Okay, like a tumor, cancer is named in accordance with the type of cell of its origin, and usually followed by carcinoma. So if it's if it's epithelial, it's followed by carcinoma, like adenocarcinoma. That means if it's glandular epithelial origin, so it comes from the epithelial parts of a gland, adenocarcinoma, and you can see that in several places in the body. Sarcoma comes from connective tissue, and lymphoma if it's from lymphatic tissue. Kind of makes sense. So melanoma, for example, what is that? Well, it would rise from melanocytes in the skin. Okay, does that make sense? Good. Let's kind of move on. Other than mentioning testing of tumors, X-ray, MRI, biopsy, however you have to get to it. Biopsy is obviously the best because you can tell for sure what kind of cancer it is. All right, let's look at cancer staging here and talk about that for 1 second. It's pretty simple, and it really depends actually on what you're looking at. Okay, because up here, for example, it'll say stage 1, stage 2, stage 3, and stage 4. But if you look down here, you also add in that stage 0, which means carcinoma in situ, as in it hasn't gone anywhere at all. I don't think my little video on here works. So let me I'll get back to that video in a second, but it is on the actual PowerPoint that we can show it. So you might want to look at that. It's just, it breaks down actually all the stages pretty well from that website. Let me see, what do I want to say about this? Well, we're talking about cancer staging because we're talking about invasion and spread. And that's one of the hallmark characteristics of cancer, are its ability to invade other tissues and spread to different sites, right? So, like I said, when it's still contained within its tissue of origin, it's termed cancer in situ. The amount of time required for invasion of local tissue and spread to distant sites depends upon the types and extent of the mutation accumulation. It also depends on the presence or absence of anatomic barriers and various biological factors. The tumor invasion is kind of the first step in this whole metastatic process, and it depends on changes in a lot of things like the rate of cellular proliferation and the amount of mechanical pressure that is actually created with the growth of these cells. It puts mechanical, physical pressure on things. It also depends on, enzyme like both lytic breaking down and angiogenic growing production of things. And like I mentioned earlier, the cellular adhesive properties is a big factor in the whole metastatic process and tumor invasion. And of course, the cellular motility and how fast that thing's going to go anywhere. Anyway, what I was going to say about this is tumor cells, they can spread to distant sites by invading either the vascular or lymphatic system, okay, most commonly. The process of implantation of cancer cells at distant locations is called seeding, okay, like putting a seed in the ground. And that's the process of implanting cancer cells at distant locations, seeding. Okay. The success of a seeding event depends on a variety of biological factors. However, the most successful metastatic events occur where there's an adequate blood supply from which angiogenesis can occur. So you'll see that in lungs, for example, where you have a lot of air and blood supply. Really common sites of distant metastases depend on the origin of the cancer, by which route the metastasis occurs. And in some cancers, preferential target organs are commonly selected. Like I said, lung is a really good one where a lot of cancers definitely prefer to go there above anywhere else. Okay? Let me, the main point on this slide, I guess, that I never really did get to, is it kind of goes stage 0, carcinoma in situ. Like I said, it hasn't gone anywhere. Stage 1, 2, and 3, basically what you need to know about that is it progresses the higher the number gets. So higher numbers indicate more extensive disease. Okay, larger tumor size and or spread of the cancer beyond the organ in which it first developed, primary, to nearby lymph nodes and or organs adjacent to the location of the primary tumor. So that's what you see in stages 1, 2, and 3, is the higher, the more you see of this invasion, I guess, and spreading around until you get to stage 4. And stage 4, clearly the cancer is spread to another organ, and that's what defines stage 4. Okay. Cancer staging, there is this link, obviously, from the National Cancer Institute, and you can go on there and check it out, the TNM system. And all that's really saying, actually, let me look and see if I have this anywhere else. No, I do not. Okay, all that's really saying is that whether the T is right there where it started, or the N is for local lymph nodes where it's kind of locally going around. So, T is probably, 0 or stage 1, and N is, maybe we think about that as 2 or 3 because it's just locally, and then M is metastasis, so it's gone everywhere. So that's all that really means is T and M is just how far it's decided to spread, and that's what we're talking about there. Again, look at the link. I can't click on it on this Prezi for some reason, but you can check it out in the PowerPoint. Yeah, it shouldn't take too long to do that. All right, tumor development and proliferation. Okay, let's look at some of these things. Let me kind of start out with this by saying that while cancer is a disease that's strongly associated with aging, it's not due to the fact that cell function deteriorates as the body ages, but rather the pluripotent or omnipotent stem cells from which all new cells arise accumulate genetic alterations as one ages, and that interferes with proliferation of fully differentiated daughter cells. Does that make sense? Let me say that again. It's not that, even though cancer is strongly associated with aging, it's not so much that the cell function in the body deteriorates. It's more that the stem cells, they get, over the years, a lot of genetic mutations or alterations, and that interferes with the daughter cells further on down the line and causes more cancer. Okay? So, when individual mutations affect the genetic information that regulates growth rate or apoptosis, the breaking down of a given cell, the progeny of that cell can accumulate more rapidly. Okay? Individual mutations that affect the genetic information that regulates growth rate or apoptosis, breaking down of a cell. It's the progeny of that cell that can accumulate more rapidly and develop an early stage tumor. Okay, so it's kind of like push down the line here. If that's the only mutation, though, the growth is benign. Okay, if you just have a where it's not going anywhere, okay, and it's still encapsulated, it needs an additional mutation that causes the release of angiogenic factors or making more vasculature. That's usually required for the tumor to expand. Okay, not to get into this too much, but we probably should mention at least before I start getting into the slide about talking about oncogenes and things like that, about the different several mechanisms that can be affected that result in increased proliferation. So let me first say that a mutation that causes the production of telomerase, okay, an enzyme telomerase, creates cells that can reproduce indefinitely. Okay, so they can reproduce indefinitely if you're causing a production of this telomerase that's in DNA replication. And if they can reproduce indefinitely, they override the normal replication potential of these cells. Okay, proto-oncogenes are genes that normally direct synthesis of proteins that accelerate proliferation. Okay? An oncogene is a defective proto-oncogene that has enhanced the ability to direct the synthesis, and therefore it stimulates more rapid proliferation. Okay, so an oncogene is a form of a proto-oncogene, and basically its whole point is to divide really fast. Okay. On the other hand, tumor suppressor genes normally slow down proliferation. Okay, when they're altered, they may lose this function and allow for more rapid proliferation, the opposite, right? Okay, so some of these genetic alterations that affect these regulatory genes, they can include point mutations, chromosomal translocations, chromosomal amplification. Okay, in some cases, a single allele can be altered, and in other cases, you need gene slicing, or the whole loss of heterozygosity is required. It just really depends on what genetic alterations, and in what cases we're talking about for something to turn into a tumor. Okay. And of course, in addition to the alterations, like I said earlier, that provide for increased proliferation, the cancerous cells also have to accumulate mutations that provide for tumor invasion, and then they have to accumulate mutations that provide for distant metastasis. So there's, three different things going on here. Okay, let's look at some of this thing now that I've kind of gone over that a little bit and see what else I have to go into. Genetic oncogenes, like we use an example here, BRCA1 and BRCA2 are breast cancer, breast cancer 1 and breast cancer 2. These are genetic oncogenes So, like I said, because oncogenes, they're defective, and they therefore have the ability to stimulate rapid proliferation or growth. So that's what they're saying right here is genetic oncogenes BRCA1 and 2 produce growth factors. It's supposed to be a comma, angiogenesis and loss of inhibition. So they basically go wild, right? Okay. Now you have a lot of different triggers that will kick these things in, these genetic oncogenes to kick in, and you can see them listed here. And obviously cigarette smoke, we know that, right? Ultraviolet light, as in skin cancer, sun, toxins, chemicals, asbestos, radiation, of course. These are pretty commonly known, I would think. Hormonal is another trigger that can kick things in. There's viruses like Epstein-Barr virus. We've seen that, right? Like Burkitt's lymphoma. HPV, we've seen that. And cervical cancer, human papillomavirus, right? Hepatitis B, you don't remember if we ever talked about that or not, but it can certainly lead to liver cancer. And then there's H. pylori that causes ulcers in the stomach, but it can also continue and cause actual stomach cancer. Okay, so we're talking about a lot of different things that that can cause tumor development and proliferation. And I didn't even mention, things like I don't know, what else didn't I mention? Air pollution, things like that. Anyway, let's move on to the next slide and see what we're looking at here. Okay, these are general neurological symptoms that we're looking at. I guess I could read down the list for you, but you can clearly see when there's cancer, you have weakness, paralysis, seizures, headache, changes in vision, sensory changes in mood and behavior, changes in reflexes, cranial nerve functions, ataxia, symptoms of intracranial pressure. It really, really depends, right, on where the cancer is, what kind of cancer we're talking about, of course. Pain is actually not common in the early stages of cancer, but it's quite common in terminally ill patients. It's suspected actually that pain is associated with cancer. The pain associated with cancer has a lot of physiological causes, of course, but also some cultural and psychogenic components too. Anyway, that's not really the point of this module right here. Fatigue is clearly the most commonly reported symptom in people with cancer. Cachexia, I didn't have listed on here, but it's kind of a syndrome of general weight loss and wasting away of body tissues. You get anorexia, anemia, taste alterations, altered metabolism. You see that in the whole cachexia, or wasting away. Anemia, of course. Did I mention anemia? No, I did not mention anemia either. But anemia can be manifested as hemorrhagic, like due to iron and blood losses, or hemolytic, usually associated with lymphocytic or myelogenic leukemia, or even aplastic anemia due to malnutrition. You see leukopenia, thrombocytopenia. They often result from tumor invasion of bone marrow and or cancer treatments, for that matter. And infection is often a cause of complications and death in people with malignant cancer. But I don't know what else to say about that. And we are kind of out of time on this video, so next time we will pick it up on the next video with cranial tumors.